Hi, today I'm going to be presenting 2020 AIME I Problem number 2. There is a unique positive real number x such that the three numbers log 2x to the base 8, log x to the base 4, and log x to the base 2 in that order form a geometric progression with positive common ratio. The number x can be written as m over n, where m and n are relatively prime positive integers. Find m plus n. Since this is a geometric progression, we can assign a variable y, the first term, to log 2x to the base 8. And r could be the common ratio, and that could be log x to the base 4. And the next term in this geometric progression would be yr squared, log x to the base 2. One important fact to note is that logs can be if you see log 2x to the base 8 is equal to y, then that means 8 to the power y is equal to 2x. If log x to the base 4 is equal to yr, then 4 to the yr is equal to x. If log x to the base 2 is equal to yr squared, then 2 to the yr squared is equal to x. So rewrite it in that form. 8 to the y is equal to 2x, 4 to the yr is equal to x, and 2 to the yr squared is equal to x. Now we see that 4 to the yr is equal to 2 to the 2yr, because 4 to the yr can be written as 2 to the 2 to the 2yr, and using the exponent formula, that's equal to 2 to the 2yr, and that's equal to x. And 2 to the yr squared, this term here, is also equal to x. We can equate 2 to the 2yr and 2 to the yr squared. The bases, which are 2's, they cancel, and you're left with 2yr is equal to yr squared. Y squared is y times r, and 2yr is just 2yr. The yr's cancel, and we get r is equal to 2. Now let's solve for y. 8 to the power y is equal to 2 to the power 3y, which is equal to 2x. 8 is equal to 2 to the 3, and 2 to the 3 to the y is equal to 2 to the 3y. And this is equal to 2x. If we divide by 2 from both sides, we get 2 to the 3y minus 1 is equal to x. There's this minus 1 over here, because in exponents, if you have a minus 1, it just means over that base. So 2 to the 3y over 2 is equal to 2 to the 3y minus 1, and that's equal to x. We also know 2 to the 2yr is equal to x. From 4 to the yr is equal to x, we derive that 2 to the 2yr is also equal to x. So we can equate them again, and the bases will cancel. So 3y minus 1 is equal to 2yr. Then we know r is equal to 2. So 3y minus 1 is equal to 4y, because 2ry is 2 times 2 times y, which is 4y. You subtract 3y from both sides and you get y is negative 1. 4 to the yr is equal to 4 to the negative 2, because y times r is 2 times minus 1, which is negative 2. 4 to the negative 2 is 1 over 16, and that's equal to x. But x is written as m over n, where m and n are relatively prime positive integers. So 1 over 16 is not the right answer. We have to find m plus n. 1 and 16 are relatively prime, and that basically means you can't simplify the fraction anymore. 1 over 16 is m over n, and since we have to find m plus n, we're going to do 16 plus 1, which is 17. And if you're giving an AIME test, then you have to write it as a 3-digit number, which is 017. So the answer would be 017.